can you write a SQL query that shows the total amount of successful posts per user type in the last month? For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. So basically, let's suppose that you work as a data analyst for a company that is a social media company, and they're really invested in growth hacking right now. So one of the key features that they really care about is how frequently people post, and also how frequently successful those posts are, because they really want to increase the usage of the post feature as a proxy of engagement for their platform. So this following series of SQL questions is going to cover the descriptive analysis to identify both the current baseline for how frequently and people are posting, and also how successful those posts are, and also new ways to increase the post engagement level. Okay, so let's kick things off first by looking at the data tables that we have available to us. Sure. So I see we have this up on the screen already. So the first table is the, there's the post table. It's actually on the right side. So each post is uniquely identified by post ID. There's the date, there's the user ID. So that's the ID of the user who made the post. There's the interface. So that can be like a Chrome web browser, mobile, and so on. And then is successful post, that will just indicate whether or not the post was successful in being posted. Okay, and then there's a user table where we have a user ID, the user type, and also the age of the user. Okay. Awesome. Okay. Yeah, so given all of that information, I'd love for us to first start with a baseline. So can you write a SQL query that shows the total amount of successful posts per user type in the last month?
Awesome. No, I'm super excited. So this ecosystem is really around user, and kind of the overarching goal is to try to understand and potentially root cause like successful posting as a proxy for engagement, right? If you don't mind, I'd love to take a step back and just ask some clarifying questions on just the kind of the data table and data structures and some of the assumptions made. I think, diagram's super helpful. The one thing that I'm seeing is like a user ID to kind of post ID, trying to understand the cardinality between that, like, is it between a post and a user? So let's say for a particular post 1 and a user 1, they failed the first time, and let's say they try to post again, will that essentially be a new post ID, or it would be the same post ID?
Yeah, so that would end up being another record in a post table, which means that it would have a separate post ID.
Perfect. So essentially like the post ID be sequential. So like someone could like unsuccessfully do like 3 times, and then finally the 4th time, like it will post ID 4 for it to be successful. Is that correct?
Yeah, exactly. Yeah.
Awesome. I think that's the main thing around just trying to make sure all those keys are delineating out. Now going back to your original question, which is like understanding the baseline post successful rates. So I think the approach, or what the outline probably looks like, is like by user, basically in one column, and then essentially another column would be like their success rate, and then we can include any intermediary columns to kind of just showcase those numbers. So from an output perspective, I'm going to do by user and essentially their post success rate. What I'm going to do first is I'm going to try to pseudocode it just to walk you through like the thinking process, and then I'll go do coding, and then we can talk about the outputs from there. Okay.
Yeah, sounds
great. So I think the one thing that we're going to first look at is essentially, so I'm going to do a select statement, but basically we'll do a column. So by user, we're going to do basically the sum of successful posts, and then the sum of essentially post attempts. And then we'll essentially take, let's see, the sum of, I'll just call it SP as successful post, divide by sum of essentially, or we can do count, but sum of post attempts.
Okay, sorry, just to clarify, when you say sum of post attempts, what is that referring to in the table?
Oh, that's essentially like assuming that is successful post is like it looks like a binary, 1 and 0. So essentially count every time they tried to post from a particular user. So it's essentially, instead of sum, I guess more semantically, it would be count is the correct way of looking at it. And that should give us our post successful rate.
Okay, so like number of unique post IDs or
Exactly.
number of
Yeah.
records.
Yeah.
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 Okay.
Exactly. So
Mhm,
hence the count, right?
Yep.
And then essentially, I think to clarify, I think you mentioned potentially there's a time component. I was wondering if you can just reiterate what kind of timing reference you wanted for this particular, or we want the whole ecosystem.
Yes, that's a good question. So if you could get the total amount of successful posts per user type in the last month.
Okay, sure. I'll do like in essentially the last current month. So create the last current. And of course, because we're doing the aggregation, we're going to do a group by, and then we'll do essentially an order by as well. So essentially, we'll probably care about people who are failing the most. So we'll order from the success rate descending. So this gives us the by user and then post success rate. Any concerns? Otherwise, we'll just get to the coding part here.
No, that sounds good. Yeah, let's see the code.
Awesome. All right, let's do it. So let's do our select statement from, and then we're going to be pulling from the post table. Let's call it as P just for simplicity's sake. Then we're going to do pull user ID. ID. And then first we're going to sum the P successful post. And then we'll essentially do this as post success. Then we'll do count. P is successful post. Post attempt. And then we'll do, since we can't necessarily pull a derived column, we essentially just recreate it line. We'll call it success rate. And then we're going to do the where clause where key post date is in a date time format. Since we're doing just last current month, we can hard code it. We can come up with a more dynamic one afterwards if we want to, but just for sake of time, we are going to do assume everyone last month. One, and then we'll also order by so post success rate, descending order. So just double checking, we have a user, there's post success, post attempts, we summarize, we divided. The only things be careful, just in case this is an integer, just make it into a float, so it's percentage. And then we do a word clause group and descend. So I believe this is it. We'll just try it out. And then if there's any issues, we'll just troubleshoot from there. So looks like it ran. We have essentially our user 9 with the best post rate, great, and user 4 with essentially really bad post rate. I think one thing to take away, at least from an insight perspective, it just seems to be a pretty big spread, suggesting that there's some types of improvement, right? It's not a systematic issue that's affecting all users equally. And it'd be interesting to kind of double click into that, try to observe what's potentially driving the issue here.
Yeah, okay. So you exactly anticipated what one of my next questions is going to be, actually. So it seems like because there's so much variation in the post success rates, I'm curious if we can then try to isolate the users who not only post very frequently, but they also have a successful post rate that's actually below the current monthly average. And we can call these like either super users or whales, because they're basically the users who want to post a lot but are frequently failing at posting.
I see. Perfect. So it's like trying to segment essentially the users that we want to really work on. So like they're the type of people who want to post, but essentially are not being able to, right?
Yeah, exactly.
Okay, perfect. I think that makes a lot of sense. So let's same thing approach. We'll do some pseudocoding here, and then we'll do the coding from their perspective at first.
Okay.
So I think when you look at this type of metric, you're trying to compare essentially the post success rate that we just previously provided in the kind of previous section, and then compare it to kind of a global limit, right? And I think this the easiest way to do that is probably doing kind of a with statement clause to kind of create the aggregated metrics and then compare them and then basically generate the table again and then filtering out what we think are the two things, right? One around post attempts and the second is around post successful rate.
Okay, yeah, that sounds good to me.
Awesome. So
could you clarify what's actually going in the aggregate table in the with clause?
Yeah, so let's from an aggregate metrics, let's talk about it first. So I think we're gonna throw a with, basically create a table. So basically create a subtable. And then what we're essentially gonna pull is the average post attempts by user. We're gonna pull essentially the average post success rate by user. And then we'll kind of generate from the table that from before, we'll create those metrics, and then essentially we'll pull the original table that we had before. And then essentially we're gonna filter out with two things, filter out with a where clause on two things. One is going to be where post attempt. So a user's post attempt is greater than equal to the average post attempts. And then two is where the user's post success rate is less than equal to the average post success rate. I think that's the approach there. Any questions or concerns with that?
No, that makes sense. So number one basically looks for our like high frequency users, and then number two is looking at the high frequency users who have a lot of failures, right?
Yep.
Yeah. Okay.
Right. And just combining, you're basically just building on the aggregate filter that we're doing here.
Right. Yeah. Okay, that makes sense to me.
Okay. So let's just get to coding. Rubber meets the road here. So let's just do aggregate metrics just to make it easier on us. So we're gonna select, so I'm gonna put this as a stand hold for now, because I think what we're gonna need to do is basically pull the user metrics first and then summarize it on the outside here. So I'm gonna have essentially from a smaller table here. So I'm gonna pull essentially what we did before, which is super simple. So P user ID. So I'd actually just copy, so it's easier. Post successful attempts from post P, that's P, and then we'll group by 1. So this will essentially get us the user. And now from here, the only thing was just give it an alias. And so then we can now pull T1 average post attempt, which is from here as average posting. And then we'll also pull average with a comma, average post success. Post success times 1.0 divided by the post attempt. So this is essentially one line to kind of do that as average success rates. So kind of, it's always good to kind of just check in between. So what I'll actually do is I'll just run this right now to make sure that this is producing appropriately. So we can see on the right-hand side, the average posting is about 250, which makes sense. There's 20 people. It sounds like it's about 1,000, just this database. And then the average success rate is about 50.4%. So realistically, when we pull the second table, we should see everyone's posting that's, above that amount, and then but above the posting amount, but then below the success rate here.
Okay. Yeah, makes sense to me.
Awesome. So let's uncomment this back out. So now we have the tables running. Now we're going to do essentially the final post, which is really bringing back that last half again, which we can just pull from before. So P user I'm going to drop the time where clause. I'm assuming that's not something that we were concerned about at this time, if that's correct.
Yes.
But just checking with you, do we still want the time clause in?
No, I think that's fine because we want like monthly averages, so we don't want just the last month.
Yeah. No worries. The only reason why I bring it up is because if we do want the time reference, like the way that we create the aggregate metrics, like we'll be comparing apples to oranges. So depending on the phrasing question, we have to put that time clause back into the aggregate metrics as well. So just something to think about if that's something that we want to do. But
yeah,
all right. A good point. So we're doing the having clause instead of a where clause because we're doing it a filter based on an aggregated metric instead of like a actual inline metric. So you can't really do a where here. So what we want to do now is we want to say the post attempts is essentially greater than equal to, and then we'll essentially do a select clause here to get the metric from before. And that metric before is average posting from aggregated metrics. So that's the first part. And then we want to do the and clause, right? Because we want to find the intersection of the two. So we will do the post success rate now. That's what we want to compare it to, is less than equal to, again, we're going to pull from aggregated metrics. So this would be average success rate from aggregated metrics. So I just want to check this still makes sense. Oh. First have that select out there first. So you're going to select, and you're going to do sum, and then you do post success rate, and do the group by, and then do the where condition that we talked about before. So when we run this, if we experience any issues, we'll fix it on the fly. But it looks like we have, out of the 20 users, it looks like we have 6 users that are considered quote unquote whales. And this is where they're, as you can see, they all post more than 250, and their post success rate is less than that 50.4% that we saw before.
Yeah, okay, that makes a lot of sense to me. Okay, so that's one way of identifying some of the users who are specifically having this problem more often. Another way that we could segment our user base is maybe by age, because as we know, younger users tend to use social media differently from older users. So could you write some SQL that instead shows the difference in success rates of like posting drop off between young adults? So those are people who are aged 0 to 18 and not non-young adults by each month.
Oh, by each month. Okay, so that's an interesting element. So is the hypothesis here saying not only is age segment, but maybe there's a seasonality to their essentially their posting rate? Is that the idea here? Perfect. Okay. So let's do some pseudocoding here. So I think that the interesting element here is that we're going to have to do segmentations within a certain column. So likely we'll use like a case and when statement. And then we're also introducing a new element of time, right? Where we need to segment it by the month.
Yeah.
So let me, go ahead.
Can you quickly summarize at a high level what the case and when statement does?
A case and when is essentially like, so a case is essentially a wrapper around as if and then statement. So essentially you'll take a column, let's say age, for example, right? So let's say when the age is between 0 to 18, you say, hey, let's classify this as young adults. If it's greater than 18, we'll classify as non-young adults, right? But this is the beauty of case and then when, then, else, and kind of syntax is that you can do multiple conditions for this. So let's say in the future, we want to do like 0 to 18, like adults 18 to 20, like 35, and then like older customers or users and like 35 and older, whatever the case may be. Like this is kind of how you sequentially can segment out your data without having to kind of break it up into multiple queries. Okay, perfect. That sounds perfect for our use case. Awesome. So I think the interesting thing about this is if we want to compare the two of them, there's multiple ways around it. I'm going to index on the flexibility side of things here. So I think the first high level before we even do any pseudocoding is like, one, let's create the aggregated metrics based on YA and non-YA by month. And then this is this is kind of less efficient from a coding perspective, but it's more flexible because you can utilize these tables. But we'll split the tables by YA versus non-YA into kind of two subtables, two subtables. And then essentially, then we'll combine them with a join to kind of compare the two. And essentially find the difference, right? And that if we can highlight the differences, maybe it will like be very poignant on what month, what particular segment is doing better. Maybe there's a difference between the two.
Okay.
Cool. Does that make sense, or anything we want to adjust there?
No, that makes sense to me.
Okay. So from the aggregate submetrics, let's just list it out. I think pretty quickly here, because I think it's very similar to everything that we've done before, right? So we're going to essentially have by month from the date time perspective. And then we'll do the case and when, conditional statements to segment out users. And the beauty of it is that we're utilizing the same metrics that we talked about before, right? So it's going to be post success, post attempt, and then essentially post success rates. So in this case, since we don't really, I've shown it many times, we'll just kind of just jump to the post success rate, just so that's easier to look at. And then because we're doing by 2 dimensions, we're going to group by 1 or by 1 and 2. So the first and second column that we see here. Then we'll create a YA table, filtering on ag metrics with the YA segments. And then we'll create a non-YA, so non-young adult table, doing the same filter on non-YA, and then we'll essentially join them based on month. So by month, the same one. We're going to compare YA versus non-YA, and then also essentially compute the difference. So I believe this should be handled everything. If there's no further questions, I'll just jump right to the coding.
Okay. Sorry, just trying to clarify like the comments you have written here. So is this meant to be okay? So there's not 2 separate joins, right? This is just like
just
expanding on.
Yeah, you're gonna join them based on month because you want to compare like month to month, but then you compare like the 2 groups, right? YA versus non-YA.
Right. So this just corresponds to what you have on line 85, right? They're not 2 separate things.
Line 80. Oh, yeah. So sorry, line 83, 85 was like the high level idea. And then 87 through 97 is more like the pseudo coding, just at least so you can track along. Because I might be writing coding and I don't just want to make sure that you're kind of locked in step with me. That's all. Okay.
So then when you're saying compute the difference at the end, so that's an absolute difference in percentages?
Correct. So it probably won't be absolute because positive and negatives do mean something. So likely I think what we care about is probably young adults, just because we're in the social media, like everyone cares about young adult. So we'll compare like YA minus non-YA. So if it's a negative, it means that YA is performing worse. If it's positive, it means YA is performing better.
Okay. And like, what about the magnitudes? Does it make sense to get like a % difference instead of like a value difference?
It's fair. So I think it really depends on what you care about, right? So I think so right now I'm just looking at the nominal difference, right? So like both percentages, so that's a success rate. So that normalizes like the posting that's happening. I'm assuming that's what you meant. While the % difference is fine, but it could be misleading, right? Without a base, because you can have a percentage of 5%, but like, what if that's like not very high to begin with, right? If the base is really low. So that's why I prefer the nominal difference versus the percentage difference.
Okay, sure. So yeah, then I guess with the nominal difference, then if you want to reference the base as well, we also have to have that output in the table, right?
Yep, exactly.
Okay.
Sure. Let me just make sure. So have the output of success rate in the table. Perfect. No, I appreciate that. if not, if no further ado, then we can get started coding.
Yeah, I'd love to see
Awesome.
the SQL for this.
Awesome. So let's do, let's call it, I guess because of segments, we'll do ag metric segments. So we can do as, and then we're going to essentially pull what we did before. So this is going to be interesting because we've done this before, but it's functionality in basically pull the month. So let's pull the table first. So P, believe D is called post date. So I don't mix that up. Post date, and then we'll essentially call that as post month. Now we'll do the case statement that we talked about before. So we'll throw this onto one, just parentheses, just in case. So case when, so in this case, forgive me. So one thing I made the assumption, but was kind of implicitly implied is that in the previous pseudo coding, the thing that we need to do in the add summary, we do need to do a join to the user table to get the age. Yeah. So so used to these things, I just simply say, oh, like we'll get it from there. So yeah. Before we get there, so let's just do the join right now. Okay. So let's join from I believe it's called the post user table. So post user table. Let's call it
that's where you can get their age.
That's correct. Yep. Yep.
Okay.
So we're gonna connect on P user ID. So on P user ID equals U user ID. So great. So the reason why that matters is because in here we really want to pull the age, which I believe is just called age. So age is less than equal to 18. Hopefully there's no one that's negative 18, but less than equal 18. 18. Then we'll call this YA for young adults, and then else we'll call it non-YA for and then essentially end. And this essentially split the two into two brackets or segments. We'll call it as age brackets. And then this is where we'll do the similar metrics that we did before, which then it's really easy. I'm just gonna copy and paste from before. Save some time, but essentially just gives our post success, post attempt, and post counts as post success rates. Great. Then we'll pull from pool. And then as we talked about before, because we have two dimensions here, we're gonna group by 1 and 2. From there, we're gonna do the next section, which is then pulling essentially a YA group, which this is a pretty like you can do a cleaner or faster way, but this allows us to be more flexible in the future. But we're gonna pull from the metrics segments where, and then with age brackets equals YA, and then we'll pull the non-YA section here. And then we'll A, which matches the top. And then we're going to essentially pull the last segment. Now we're going to combine the two to compare them, right? So we're going to do select, and then we're going to do from, we'll just pull YA as the basis. So pull YA as, say, table 1, and then let's join the non-YA table, table 2 on T1 post month. So we are using an inner join here. So the only thing that I'm making, the only caveats to this output is that I'm only going to compare where YA has a value. If YA doesn't have like a month, for example, but non-young adults did, then that essentially would potentially be eliminated from this particular view because it's kind of trivial to not look at if you don't have a comparison between one and other. And then we are going to try to we'll do an order by just to kind of make sure it's like sequential order month. But let's pull in the post month. That makes sense. Then we're going to pull in the T1 success rates. So I think it's called post success rates. And then we'll call it, just so it's easy to look at, by success rates. T2 post success rate as non-YA success rates. And then, because again, this is a derived metrics, I can't just pull a derived column here. We're just going to do T1 minus T2 previous. And then we'll say this is as their diff. So just trying to think through your T1, your T2, your on, and then we'll order by T1 post month ascending, so that we get month basically chronologically, and we can look at this. So we'll run this again. If we hit any bugs, we'll resolve on the way, but thankfully there are no bugs. But just trying to give some quick insights from looking at this. We'll see like month 1, 2, and 3. I'm assuming that corresponds to January, February, and March. What's interesting is that there is some variance. Young adults tend to perform, out of the 3 months, at least within this data set, performs better than non-young adults. And then the only discrepancy is really within the month of February. Off the top of the head, the only thing I can think of is maybe Valentine's Day, but we can kind of explore further if that really has a driving factor here. But it is interesting to see the segmentation here.
Yeah, okay, I think that makes sense as a hypothesis. And like, just out of curiosity, then, if you were to try and explore what's behind that discrepancy, do you have any suggestions for what types of analyses you would do?
Yeah, I think so. From a young adult or non-young adults, what would be really interesting is like, even in, so let's separate the two things out, right? So just so you don't confuse like a multifactorial problem potentially. So like in the month of January and March, you really want to see like, why are they consistently, like, all young adults are posting better? Is it a particular time of day that they're posting that, let's say, young adults are posting throughout the day versus non-young adults, maybe they're posting like after work, and maybe it's an overloading on the system that's causing them to fail. Like that's a time component that could happen. So that's just from an age segmentation. From a potential seasonality component, I would be really interested in see like any anomalies around like holidays. So like, is the Valentine's Day really driving the February indication? Is it, non-young adults, maybe, they're more in established relationships or willing to post, while young adults, maybe they're still in that kind of early phase. That's why they're not posting as much. But there's a lot of other segments and cuts that we can go after this too.
Yeah, okay, that makes a lot of sense. Okay, so far we've been exploring this like post success rate as a function of the user segment, whether that's been before by like whether or not they're a whale, or by their age group. But perhaps we could also hypothesize that this is actually a systemic issue. It might be something to do with the tech, like maybe a specific user flow in the interface is actually causing this issue. So if it is a systemic issue, one way we could look at that is by looking at whether or not it happens consistently. So if a user tries to make a post, it fails, and then they immediately retry again, does that second retry fail as well? Could you write me a query then that shows each user's success rate of posting when their previous post has failed?
Perfect. I think from a simplicity perspective, just off the top of my head, we can do essentially the next post that they do. I guess the one caveat that we're not considering is like how long between the posts, but maybe that's something we can save for another time. But more than happy to do that here. So I think the interesting thing about this is, unlike the previous kind of sections that we're talking about, this is like you have to almost create a sequence within SQL to kind of know what is the next post for each user. And this is like a perfect application for like the partition, or basically a windowing function here. So I think the kind of a high level before we do pseudocoding, like I think the first thing you want to do is that essentially create a post sequence. Comment this out so it doesn't run. Post sequence for each user. So basically, like if you look at their total history, you'll take their very first post as 1, and then sequentially go down. The reason why this is important is that you start indexing each of their posts so that when a post does fail, let's say post 4 fails, then I know to pull post 5 and so on, right? By using essentially an indexing here.
Yeah. Okay.
I think what we'll do next is we'll do the post pairing, which I kind of talked about. Post pairing, where you're where we're filtering out the previous post as a fail, and then basically pulling the next index, and then it kind of brings us back home, and we keep hitting this on the head, but essentially calculating the post success rate of the next post, or basically the next post here. So I think at a high level, that's gonna help us solve our issue. So I'll just jump right into the kind of the SQL coding here, or the pseudo coding. So I think what we'll do first is we'll create a subtable, and we're gonna basically dimension it by user and post ID. And then we'll essentially create a new column called row number, or basically post sequence. Basically, this is going to create the window for each user perspective, and then label each post with an index. And then we'll also pull in what's most important probably is the fail or not fail. So we'll pull the is a successful post or not.
Yeah.
Then we will create I guess the easiest way of talking about is a post pairing table, where we will pull, so it's easier to look at. We'll pull from the index table that we just created before, but we'll do a where clause where the previous post has failed.
Okay.
And then we'll combine the two. So so for example, the output here would essentially be user post ID and then a next post. And then you're only filtering on essentially the post that has failed. And again, I'm breaking this out steps so it's easier to kind of manipulate. Again, you can kind of consolidate this as necessary, but this helps if you ever need to do anything else with it. Typically, you want to just break them out so that it's easier to work with in the future. And then essentially the last table is essentially doing the summary matrix, where you're going to join essentially, the original post, kind of the original post information. And the reason why here you're getting the post information is you want to essentially tag the sequential post. If it failed or not, which you couldn't really pull from before. You could, and then we'll just summarize from there, summarize the metrics. So the only thing about this join is just to kind of list it out. It's going to be post ID, the post ID on the next sequential post ID. It'll make more sense once you kind of go through the coding here, but just want to at least give a preview on what we're looking at. I'm gonna stop right there, just checking with you. This is my thought process. Anything you want to adjust or any questions you have here?
Yeah, no, I think that makes sense to me. And what do you mean by summarize the metrics at the end?
Oh, it's always the same metric that we talk about. So it's really going after post success or secondary post success rate. Okay.
Yeah, so just the success rate of the second post after the original failed one.
So essentially we should have user and then next post success rate as the next column over.
Okay, perfect.
Awesome. So why don't we get added here? So again, we'll create that with, and then post sequence as, so we'll create the subtable. So let's do our select from post as P, where this is where we're going to pull the user ID. We're going to pull in the post that we talked about before. And then the new thing that we're doing here is essentially the row number function. And then what's interesting is that we want to do it over a window where we are partitioning by, so basically a subgroup by partition. Oops, too many T's. User ID. And then we're gonna order by essentially, because we care about the sequence, and the sequence is really driven by the post date here. So this is gonna be the post sequence ID. And then the very last thing we're going to pull in, of course, is successful post. So that will should be the first sequence, or kind of create the sequence. Now we'll do the post pairing table pairings as. So select, we're going to pull in essentially what we're going to pull, the post sequence table. Let's call this PS, just for simplicity's sake, and we're gonna pull in PS.user. Fat fingers here. Post user ID. We're gonna pull in essentially the PS post let's call it post sequence ID. Okay. We'll call this as the fail post ID, for example. And then we're also going to pull in the post sequence ID, and then we'll do +1. So this is going to get the next post. So as next post ID. Okay. And of course, we can only call a fail post ID if we are filtering the PS successful post equals 0. So this is essentially going to pull in only the failed post and also the next ID's post.
Yes.
So the reason, so this would essentially look at user and then like say 4, 5, and then 6, 7 for whatever case example. But this is really important because now we can combine the two of them. So let's first create let's pull from post pairing, because that's the one that makes the most sense. Let's call this PP. And then we'll join with posts as it's called P2, just so it's no confusing. So we're just pulling from the original table now, where PP's next post ID equals P2 ID. And the reason why I want to do that is now we're going to pull from user ID. And then we're essentially going to pull the metric that we've always pulling before. But there's a caveat here. So we're going to pull P2's is successful post, and then P2's is successful post to kind of get the as, and then we'll call it, so it's easy to read, next post XC rate. And then because we have one dimension here, we are going to do a group by 1, and then just for simplicity's sake, we'll also do the next post success rate. And I guess what makes the most sense, probably ascending order, to say like what's the most problematic folks.
Okay. So, and to clarify again, group by 1 is grouping by the user ID?
Yeah, correct. So the index of like 1, 2, or 3 is basically the order, the columns. So in this case, I'm saying group by 1, I'm trying to group by user ID. I could explicitly write out user ID, but this is typically just allows more, flexibility.
Yeah. Okay, that makes sense. Yeah.
Cool. So again, we'll run it, and so there is just a error, and I just want to make sure if I row number over partition by user ID, just want to make sure. Oh, just a syntax here is partition by. Awesome. So we ran into an issue. This all looks correct, fix the by in order, but I think it's because it's simple issue here. It's just every time because I'm running on multiple lines of code, just add that semicolon to kind of cut off the previous code. Yeah. And then now simplest thing gets you, right? And perfect. I think we now have essentially by user and the next post successful rates. So I think just some quick thoughts here, just looking at the discrepancy. When we previously looked at the user ID and success rates, it's a lot higher, right? It was like 60% to 40% span range.
Exactly.
Now we're seeing it down to like the range of 35 to 51. So I think your original hypothesis that, hey, maybe there is a technical issue, like maybe people are like trying to hammer in a post that it's not being successful, and that's what's potentially causing a pretty low rate. And this sequential analysis kind of points at that right direction. Of course, we need to do a little bit more digging to make sure that's truly the case.
Right. Yeah. So essentially, you showed here that the probability of the next post attempt failing is higher for if the initial post failed, right?
Exactly. Yep.
Yeah. Yeah. Okay, perfect. So I think this is a great place for us to pause. I think you've answered a lot of really cool questions and formed a lot of really cool hypotheses about what's going on here with the post success rate. So I'd love to hear from you first. What do you think went well about this interview, and what do you think you would change going forward?
Yeah, I think so. Really interesting questions. I really appreciate you walking me through this. Like, it kind of brings me back to the old days in Meta. But that being said, I think what really went well was like being able to document the thought process. Like, for example, even though we hit some couple snags in terms of like just syntax issues, I think it came across that, hey, I knew what we're trying to do, and it was just simple, semicolons or like simple like syntax that was dropped off. And I think it's really important as candidates go through this is that it's often more important to show your thought process than like trying to write the best code, right? Because I've seen the opposite before where people write the best code, but they can't explain it. That's really where like you can't really understand like how good they are. In terms of like opportunities, I think this is like a coding preference. You can be like the most efficient SQL out there. When you look at kind of, the way that we coded it today, it's not the most efficient, right? But it's done within reason, right? And I think the important thing is to understand the trade-offs and to be able to explain that. Like for me, it's always important to kind of build those sequential tables because I'm often doing analysis based on a previous analysis that I've built. Yes. So instead of having to like, strip apart a black box of code, like I can say, all I need is this subtable, right? And build off of there. So I think as long as you explain those preferences, like those can kind of help you not have to write the most efficient code. Like even this last sequential coding, I could have pulled the second last table into that second table, right? So I didn't have to do as many. That's something you think about just from a trade-off of like timing and also like memory usage that you're using as you're running this code.
Okay, perfect. Yeah, I agree with a lot with that point. And it's efficiency, not just from the standpoint of performance, but also in terms of whether or not the code is being reused too, right?
Yeah. Yep.
Yeah. Okay, so that makes sense. So some other things I had to say about this is that I really like that you ask clarifying questions throughout because this case study in general, there's many different ways to interpret it. You could have used different quantities to measure the things that we were talking about or to answer the questions. So that was really important. And I also like that, as you mentioned, the thought process is really important, right? Because you're trying to communicate what the data says to somebody else, presumably your product team. And so I really like that you had the pseudocode and you wrote out what the queries were going to be step by step. Yeah, and so I also liked that you ran the intermediate queries instead of like just coding everything all at once and then running it at the end, because that's more clear for whoever is reading your code to understand. And also it just like helps you debug bugs earlier if you do have. Lastly, I thought that you showed a great depth of knowledge of just various different SQL constructs. Like we went through some joins, we went through filters, we did group bys, aggregations, and window functions. And I think all of that was really informative and educational. So some things that might also be helpful is, so with a lot of case interviews like this, oftentimes there will be quantities that can be somewhat ambiguous in how you measure them. So for example, one of our questions focused on the drop-off rate of post-success between like young adults and non-young adults. So drop-off rate could be a percentage, it could be like an absolute value. And I think it's just important, whichever one you choose to implement, for you to just explain and justify your choice of that. And one last question for you is, you sort of touched on this and then we kind of moved on past it. How would you be able to avoid like hard coding the dates in the first question where I asked you to do only from the last month?
Yeah, so in SQL there is like, so it really depends. Like you still need a reference, but like a date add or a current or interval add.
Yeah.
Sorry, a combination of a date add with the interval function allows you to do essentially very dynamic dates. So let's say, for example, like I wanted to do the first date and last date. Like let's say first date. The easiest way to do it is like select so date add. By the way, I didn't know if you want me to go here, but I figured it's better for our folks who's watching. So you can essentially pull the current date, and then you do interval minus the day of current date. So really, what you're trying to get. So let's say today is the forgive me, 20. I'm really bad. I'm like 24th, right? So you're pulling the day 24 out, and then essentially you want to do as a plus. You're gonna do +1, and then you're gonna say, I want to essentially minus 24 plus 1 day, and that should get you your first day of the month.
Right. Okay. Perfect. Yep. Yeah, and that's all I had. Thank you so much for joining us today, Andrew. I think we really learned a lot from you, both about the data side and the business side of these types of case interviews. And thank you everybody for watching. Good luck on your upcoming interviews. Bye, everyone.
Good luck. Bye. Thank you.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.